Trigonometry, Chapter 4, Graphs of the Circular Function, Section 1, Graphs of the Sine and Cosine Functions, Video 6, the Graph of the Cosine Function. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous videos, we constructed the graph of the sine function and saw an interactive relation between it and the unit circle. We explored how to change the amplitude and period. In this video, we construct the graph of the cosine function. We constructed the graph of the sine function by extracting relevant information from the unit circle. For the function f of x equals sine of x, the inputs corresponded to the arc lengths on the unit circle, and the outputs corresponded to the second coordinates of the associated points. For example, from the circled part, we extracted the point pi over 3 comma square root of 3 over 2 for the graph of f of x equals sine of x. The resulting graph essentially connected all of the points extracted from the unit circle, giving us this. One cycle of the graph of sine has a period of 2 pi, a midline of y equals 0, an amplitude of 1, and the behavior at the quarter periods, starting at 0, are mid, high, mid, low, mid. To construct the graph of f of x equals cosine of x, we essentially do the same thing. This time, though, we use the first coordinates of the ordered pairs on the unit circle as the outputs of the function. Recall that the unit circle definition of cosine is the x-coordinate of the point corresponding to the arc length. So our outputs for cosine will correspond to the first coordinates of the ordered pairs. Now, notice that the first coordinates of the ordered pairs on the unit circle follow the same pattern as the second coordinates. For example, over here in quadrant 1, the first coordinates are 1, square root of 3 over 2, square root of 2 over 2, 1 half, and 0. But going through quadrant 2, the y coordinates are 1, square root of 3 over 2, square root of 2 over 2, 1 half, and 0. So the pattern's the same. They just start at different locations on the unit circle. Now, as a consequence of this, the graph of f of x equals cosine of x will have the same shape as the graph of f of x equals sine of x. It will just start at a different point. Now, let's start by focusing on the quarter period points. The period will still be 2 pi, and hence the quarter periods around the unit circle will still be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Using these as the x-coordinates, the ones in yellow, for the points on the graph of cosine of x, we build ordered pairs where the y-coordinates are the cosine values, the first coordinates on the unit circle. Our quarter period points are at 0 radians, cosine is 1, so 0 comma 1. At pi over 2 radians, cosine is 0, so pi over 2. At pi radians, cosine is negative 1, so pi comma negative 1. At 3 pi over 2 radians, cosine is 0, so 3 pi over 2 comma 0. And at 2 pi radians, cosine is 1, so 2 pi comma 1. Here are these points plotted on their own coordinate plane. Now, does this shape look familiar? Well, without prior knowledge, you might be tempted to draw a V shape like this. But if we actually plotted all of the points we could extract from the unit circle, it would look more like this. When connected smoothly, the graph resembles the sine graph. Here's a larger view of the graph of f of x equals cosine of x, going beyond one cycle. The graph of cosine of x has the same shape as the graph of sine of x, except the graph of cosine starts high at, that should say 0 comma 1. That definitely needs to be fixed. Much better. The graph of cosine starts high at 0 comma 1. So here are the features of the graph of cosine. It shares many properties with the graph of sine, by the way. Did that graph move a little bit? Looks like it did. Oh, well. Number one, both have a period of 2 pi still, but we already knew that. Number two, both have a midline of 0, y equals 0, and an amplitude of 1. Remember, the graph just moved over, so none of those features changed. Both have quarter periods of pi over 2. However, starting at x equals 0, the points at the quarter periods for cosine are at x equals 0, there's a high point at 0, comma 1. Got it right that time. At x equals pi over 2, there's a middle point at pi over 2, comma 0. At x equals pi, there's a low point at pi, comma negative 1. At x equals 3 pi over 2, there's a middle point at 3 pi over 2, comma 0. And at x equals 2 pi, there's a high point at 2 pi, comma 1. These 5 quarter period points, high, mid, low, mid, high, will be key for sketching transformations of the cosine function. Don't know why there's a comma there. One closing comment. We can adjust the period and amplitude of the graph of f of x equals cosine of x the same way we can adjust the period and amplitude of the graph of f of x equals sine of x. For example, consider the function f of x equals 3 cosine 4x. The amplitude is 3. The period is 2 pi over 4, which is pi over 2, making the quarter period 1/4 times pi over 2, which is pi over 8. The quarter period behavior occurs at x equals 0 plus pi over 8, and then 2 pi over 8, which reduces to pi over 4, then 3 pi over 8, then 4 pi over 8, which reduces to pi over 2. Good, that's the period. And the quarter period behavior is still high, middle, low, middle, high, giving us a graph that looks like this. Period is pi over 2, quarter period is pi over 8, amplitude is 3, high, middle, low, middle, high. So it works just like sine, just starts at a different place. Now you try. Pause the video and try the following. For the function f of x equals cosine of x in its graph, find these things. If you haven't paused the video and tried it yet, here's your spoiler alert. Solutions in 3, 2, and 1. Everything's the same except how the quarter period behavior begins. Cosine starts high, middle, low, middle, high.